Thanks everyone, and thank you for staying here late in the afternoon. My name is Giuseppe, and I run a software company that, where shall I point this thing? Everywhere. That has recently been involved in a project which is called the Data Highway, which is actually funded by Sicily region, and it is about e-tourism. So it's basically about developing digital solutions for increasing tourism in Sicily. But the specific focus of the project is on open data, and specifically linked open data. So, spoiler, the LD in NGSI-LD stays for linked data. Let me go to the next slide. So, as I already said, the goal of the project would be to develop this kind of intelligent and maybe interoperable data structure for smart tourism and cultural heritage. So the overall infrastructure, by leveraging a well-known standard, okay, for open data. And we have chosen an NGSI-LD. I'll come to that in a moment, that is able to enable kind of a seamless access to data sources and kind of also support the reusing of data. So that would be the overall goal of the project, in theory, of course. But then reality is, of course, much more difficult, and basically our data sources are of two kinds, right? Normally you can find data in unstructured text, like blogs or websites or books or PDFs. So data is often locked inside these unstructured sources, or can be already be available as open data, because you know that administrations already have the obligation to give open data to citizens, but usually this open data in structured form is very often of poor quality. Okay, so this is the reality that we had to face in the project. So we needed to exploit and absorb all this open data, but mainly we face the issue that on the one hand, you have it locked in unstructured descriptions or text, or it is of kind of a poor quality. So in the next slides, I will focus mainly on problem number one, because the project is quite big, and we also faced the problem number two, also by using an LLM chain to clean up data, which is very much similar to what was shown in the presentation before mine. Their LLM in there was used to clean up data that is already structured, okay? And we also put up a similar solution. If you want, we may go in details if we have time, but I will now mainly focus on bullet point number one, okay? So what is NGSI-LD? First of all, it's a European standard, which is being developed by ETSI, which is the European Telecommunication Standardization Institute. So mainly it's one of the three big European standardization bodies, okay? It's mainly focused on telecommunications, but now is a little bit more turning into data. So there's a technical committee inside ETSI, which is called the TC Data, that, among other things, standardizes this data model and API. So NGSI-LD is not only a data model, but also standardizes the API, how you access this data through an HTTP interface, okay? Here, this is a simple NGSI-LD entity. So the world in NGSI-LD is composed of entities. Each entity has properties and can have a relationship with other entities, okay? So this entity here has this ID, which is the Giardino Bellini. Type garden is located, is a relationship with another entity, and this is the ID of the other entity, meaning that it is located in Catania, which is another entity, right? Which is, of course, not shown here. Location is a property, specifically a geo property, and the value would be the position of this is a standard, the value is a standard, the GeoJSON thing. Okay, so it's built on top of JSON-LD, so we are at the heart of linked data and enables digital twins because we can also have properties that mimic functions, so you can have actuation. You will not only be able to read the property, but also if you change the value of the property, you would be able to actuate, like switch off light or turn on a sensor, this kind of stuff. Coverage of the project so far, thousands of entities plus more than 100 unique types. Many of the entities map open data about lines of transport, like bus, trains, this kind of stuff. The important thing is that NGSI-LD as well, because of the relationships, it's actually constructing a graph on the data, right? Because you have nodes and then relationships among nodes. The important thing is that you can, through the API, you can have graph queries. So not only traditional queries on the data, but also graph queries, so that you, for instance, you retrieve one entity and then you retrieve all the entities connected to that entity, going across, so transversing the graph of the data graph. One small thing also about how data can be federated, so that you can have multiple sources of data, and you can then run a distributed query on top of that. Okay, so let's focus now on the main topic of the talk, which is the LLM toolchain. So in here we input an unstructured text, and then we have 4 steps. The first step, each of them is baked up by LLM, by the way, okay? So the first step, we tell the thing to identify facts and relationship among them, okay? So each step is baked up by a fine-tuned prompt engineering. So in here, we input unstructured text. In here, we output structured JSON. Then we feed this structured JSON to step 2, which basically transforms secondary facts into properties embedded within existing entities. So transforms, let's say, useless entities into properties of existing entities. Step 3 is the relationship creation, where we actually create the real graph among entities by using the support external services. I'll go into a little bit of detail, step 3 in a second. And then last step is scanning if entities are missing and creating new entities, and then translating the JSON into real NGSI-LD formatted entities that and are stored into this NGSI-LD broker in the NGSI-LD ecosystem is an open source component which acts like, imagine it is like a database, but you can do HTTP queries to it. So this is an open source component. Okay, so as promised, a little bit of details on step 3, which is basically one of the toughest things that you have to face when you create the data out of unstructured text is identifying which entities are the same. So this is a little bit of an entity fusion step. Okay. So maybe we can quickly skip, but here you see a typical geo query where you ask the location and then you ask the types and then near to a point to find similar entities to do data fusion. These are example prompts, so then maybe it's not worth now going into the details, but really you have to fine-tune these things to make them do what you really want. And this is two example inputs. So as you can see, it's a description of two events. And performance, which is maybe the interesting part. Llama, DeepSeek, Phi, and GPT. As you can see, the best performing ones are, on the one hand, the GPT, which is you have to pay a lot of money to do this. And surprisingly, Phi for Mini, which is the Microsoft one, this is open source. This is, you have the weights, this is open source, and it's not even as big as the other ones, which are respectively, these are 3 billion parameters. This was 2 billion parameters. And this GPT, you know, nobody knows what's going on inside it. So again, this is consistent across all metrics of performance metrics. And by the way, all of them, we run them locally on our machine, 32 gigabytes. Of course, GPT, no, it's external API calling. So final considerations. We devised a viable method involving knowledge graph to automate the translation of natural language data into structured JSON and then translate it into NGSI-LD. Need the intermediate step of disambiguation. Performance. Models often hallucinate, as we use this term, which I don't like that much, but still you can find an open source model that fits your bill, and of course now things are quickly evolving. So thank you. If there's any questions or anything you want to, feel free to ask. Thanks a lot.
Thank you, Giuseppe.
Oops.
And to the 6, 7 of you in the room, do you have any question or some doubts?
I'm sorry, I don't know if I missed it, but we were talking in the beginning about the cultural aspect of the data. How would you see this data used from a cultural point of view? So like the real life application.
Yeah, of course, that was quick, and sorry if I missed it. Maybe
missed.
And people from the project will kill me because I mentioned the technical aspects, but none of the real goal of the project, which is increase tourism and such. So the point is that data is centered on tourism. For instance, we have a use case where these guys, they developed a front end that works on the data that we have in the back end about e-bike rental service. And they added this audio guide data. They injected this additional data into the platform, and it's open and for everybody. So they have some kind of a path between the throughout the monuments of the city of Catania. So basically, it's open data is available in the platform, and they used it for developing this kind of stuff. Other example applications are: you go to this Mount Etna, you go and hiking in the mountains. So we have data about all the possible paths throughout the mountains, or we have all sorts of applications which are centered. We have a social media application where you can leave your comments on the monuments, and they are attached to the monument like it's a geo-referenced comment or contribute, or even photos or audio contributions, which when you walk, they will pop up because you are close to the monument. So basically, when you pass close to the monument, you will see comments from other users of the platform. So basically, we have developed many vertical use cases, applications, all of them working on the same platform, on the same, let's say, infrastructure, this data highway infrastructure. So sorry if I didn't mention this.
No, thank you very much, Giuseppe. And as I saw all of the application examples,